So the last time we didn't have not enough time for some cases, and before I jump to this rest of cases, just remind the rules are the same. So you can, I will have a slot after every case to discuss it. So please ask the question, share your experience, make remarks. So you're welcome. I also would like to make some small updates for the first use case. We have a lot of discussions. Last time. Just for reminder, the case was about dangerous sharing, that the sharing of the domains really disturbs the teams, and solution was basically multiple step solution, but in the first step, we just create a copy for the domain to make it teams independently, and also later on extract the services. So I just hear the record and would like to make some small updates here regarding sharing modules and services. So there's of course some cases when sharing itself is okay. For example, if team A produce some module with public API, and team B use this model using the API. So the model is intended to be used, and team A is responsible to manage API in compatible way, or deprecate it and inform the team about incompatibilities. Also the same with so it's absolutely okay to have it. The same with the service. So if team A produce some service and team B is dependent on the service, they call the service, it's also okay because they call public API and team A pays about this API. It's of course not recommend to have a lot of chain of synchronous call and that produce also a lot of dependencies and make a software not robust, but basically it's absolutely okay to call API produce another team. Yeah, it's also good. What is not good from my point of view, when we produce some model A and team B use it in a case which is not designed to be. So yeah, have some implementation details and you depend on this implementation details, because every change in this implementation details by model A will break and will disturb team B. So this is what I don't accept. And it's a bit rarely the case, but it also sometimes happens that the service is also called in not intended ways. You have, for example, some internal API not exposed as a public, and we depend on that call. And again, any incompatible change will break team B in this case. And the last case, what basically we have in this situation, in the case what I described, is more shared responsibility. When the team A and team B make code changes in the same model, and this is really helps. So this possibly to avoid. So we need to clear responsibility between the team who is modifying, who is make updates in the model, and who is responsible for that. Any question regarding that? So let's go ahead. So I will start with the point when I finished last time. Yeah. Okay, the next case, what I would like to present is a cargo cult. As a question, do you know something about cargo cult, how it, where it was, and what is the idea of it? Somebody knows about that? So I will explain then a little bit this part. So cargo cult was developed in the Islands in the Pacific Ocean after the Second World War. So after the Second World War, there's a lot of American military bases on this islands, and Of course, they delivered some goods, some food, and the American soldiers just give some food and some goods to the inhabitants of the islands. But in one day, this military basis was removed, basically was not exist anymore. And inhabitants suddenly see that there's no food anymore. So there's nothing falling from the sky. And what they do, they try to build kind of military objects like radars or jets or weapons with hope that it helps to bring their food back. So this is a cargo cult. And I see very similar situation. Sometimes it's very similar situation in the IT. Symptoms of that ritual inclusion of the code, so not because you understand or need it, but it's because of ritual. It's copying code without understanding how it works, or applying design patterns. So I know 10 design patterns, and I would like to use it in code without any reason and without understanding why it's good or bad in this case. Also, the architectural symptom of the cargo cult is sometimes we're making system too flexible, so have a lot of over-engineering. Adopting different types of databases, configuration source, communication never used and never requires. So context of this case is, so we have implement framework to discover, configure, and secure web services. And we do it for the flight modeling company, was about 10 developers in this case. And the architecture was extremely flexible here. So we have configuration layer with all possible stuff is a file-based database, subversion, Git. Model have different implementation. Repository layer has SQL, non-SQL database, file-based possibility, and communication also abstract the asynchronous, asynchronous communication. So there's abstraction layer between. So a huge amount of code, a huge amount of testing for nothing. So we never use in the 5 years with the supporting projects, never of the other implementation was used. Lesson learned for this project. So very often abstraction in the system design are leaky. So you cannot really abstract the things. A good example is synchronous asynchronous communication. You cannot really abstract because it's different, quite different another philosophy behind of this. I would say that I'm a big fan of the layers. That helps in lots of cases to decouple the different levels of implementation, for example, persistency from service layer on from controller, but do it really if you need this decoupling, not because of fashion or coolness. And be pragmatic, but predict a bit system involving. So system could involve, and some things could, of course, change. Make a flexible system that you can update. This is this case. Any question regarding that?
But why the system was so flexible? Maybe there were requirement about it, or team expected that it will evolve, but yeah.
Yeah, if there are some requirements, of course, that makes a lot of sense to do this flexibility. But in this case, was done only because engineers think that perhaps in some years we will have a new requirement and we will need it. But in the practice, it was never used. So of course, if you have requirements, you need this flexibility. It's absolutely okay to make an abstraction and make multiple implementation. But I see in a lot of projects this pattern that it's a kind of over-engineering. So engineers like to make this more sophisticated and abstract and flexible, and sometimes it's really make a complex. The project's complexity grows without any reason. Any more questions or remarks? Okay. So let's go ahead. Next case. Next case, I name it horizontal split. Could also say convey law, a community convey law. What happens in this project? It was a kind of platform of chain control. And it has very straightforward business logic, but high scalability requirements that should be scaled a lot. It was a team about 10 developers. And what I see is not only in this project, but in a lot of modern projects, there are two groups of people, kind of two communities. Yeah? The first group is young, active, and say Java is kind of COBOL of these days, as legacy, legacy language. Could be not Java, could be some other language, but say, yeah, we have something new to try. And another group, we will work with JavaScript or normally it's front-end people. And group two say that you cannot really build a label program with JavaScript. You just build something ad hoc, some spikes or some POCs, but it's not really for enterprise or production. And these two communities have a bit conflict, have a lot of discussions. And what happens often, I also say it not only in this project, there is the first group fit quite good for the JavaScript frontend, and second for Java backend. And there is some JSON API between, and we split in this way. We split these teams. Yeah. So these communities will on the different part of the project, so in the different teams. That, from my point of view, really bad decision. It's kind of organizational part of community part influence the architecture. Why it bad from my experience? Because every productive feature that should be implemented requires communication between these two teams, and one team is always dependent on the other. Yeah. So any feature we need to discuss, a lot of meetings, a lot of communication between. One group should always normally front end waiting for the back end and say, yeah, you're too slow. And what I see also in this project, this front end team create a secret full stack team that produce kind of backend without waiting to avoid to waiting of the backend. This is basically the result what happens. So instead that, my suggestion to so instead this layering split of the team, try to do and also backend only split. That happens also. Have kind of system of system. So that every team has more or less independent end-to-end functionality. They can deploy in the production, could have a value for the customer. Is not always the case, of course. We not always produce independent user interface, but this is the ideal case that the team has minimal dependency and feature will be implemented completely as a team and tested end-to-end in the team. Any questions regarding that?
I have one. Like I totally agree with this conclusion, but I have a question. What do you think? Like, let's say, yeah, one team developing both backend and frontend, but we have another team who do, let's say, deploy DevOps things. Like, do you think that it's like all your disadvantages are also reasonable in this case?
Yeah, I would say yes, basically yes. It's perhaps as good in the beginning that you have a specialized DevOps team who helps set up the environment and helps to educate the developers. But in the process of developing project or product, I would suggest that development team takes also responsibility of DevOps. So they understand the infrastructure, they be able to deploy, be able to fix infrastructure problems, they calculate the resources what needed for the system, and takes more and more. It happens not in one day, but they take more and more responsibility. And it's it's really also psychological thing. So if you know that your code will run in the production, and you're responsible for that. So if, for example, online shop failing, you will have to call in the night and you should repair it. So psychologically, development process also changed in this case. So I suggest, yes, to take over DevOps knowledge, DevOps stuff into the team, and have kind of full stack team that have DevOps, QA, front end, and back end. This is, of course, it's ideal case, and but this is the things what we would like to have.
Yeah. Okay. Thank you.
Okay, let's go ahead. Next is quite positive case, I would say, in comparison with disaster, which I showed before. I name it improve with less intelligence, and I see these cases more and more in the practice very often. It was a bank that have a collection of a lot of shelf systems, and they have kind of integration broker, magical integration broker. It was a commercial product, enterprise product, that have a lot of intelligence. So So you need even download the Eclipse-based graphical interface to graphical user interface to configure the stuff. And it took a lot of the typical broker functionality, like kind of routine conversation transformation. But unfortunately, what is really bad, it takes also business logic inside. And this graphical tool have some blocks and connectors between them, and people that try to implement also business logic using this tool. And this was really bad experience, because there is no unit tests, there's no real continuous integration continual developers, so it was a real disaster to develop. How to go out of this situation? Instead, this huge magical broker, we just provide a normal PubSub messaging system. I think it was RabbitMQ in this case, and it took only broker functionality. So it's responsible to receive and send the messages. It has some error handling, deadlet queues, but not more. Not any transformation, not any business logic. And business logic we put in the small piece of Java codes is adapters. So every system has own adapter that's packaged in the Docker container, deployed. I have very good test coverage of that. And also, it was really nice, we make a kind of strangler pattern. So we don't replace system in one step. So some of the connectors works already in there with new interfaces. And the rest of the system continue to work with this magical broker that there's only few people in the world who understand how to configure it. So the functionality, a lot of functionality that should be on the endpoint, not in the pipe, it was moved into these adapters, especially business logic. What is the lesson learned? So I really recommend to keep these rules smart and poor and dumb pipes. So don't put a lot of functionality, a lot of responsibility into the pipes, even if you have nice names like a service mesh. So don't do it, because it's really difficult to test and it hurts. And again, so sometimes specific solutions have more feature and more value as a generic solution. So implement special adapter for every system, what easy to support, as make a kind of universal configuration that fit for all of them. Any question regarding that? Did you see something like this in your practice?
Well, the first thing comes to my mind is like when you have, I mean, it's probably a bad analogy, but when you have business logic in your database, like in some procedures, so it's quite simple. You can't test it, you can't, yeah. So it's
Yes, really, it was some years ago. It was very popular to put some logic into the storage procedures, yeah, or Oracle forms. Yeah, who works with that? Yeah? And it's also basically it's a similar problem. It's very hard to test, and that is database specific. The migration is difficult. Yeah. So also at least it shouldn't be a business logic there, definitely.
Yeah, so database should be done like a Python. Yeah.
Okay. The last case what I have to present is I name it freestyle architecture, and this was in the beginning very positive case, very modern. So we have it's e-commerce online shop, retail was about 100 developers, and they built the kind of what I really like self-contained teams. Yeah, so they combine the front-end developer, back-end developers, and DevOps in one team, and team is responsible for certain business subdomain. And it was quite a good decoupling between the team. So from my point of view, as far as you have more developers in the project, you need to have a higher decoupling grade. Yeah? So if you work perhaps only alone or few developers, it's enough to have your methods. Then you create some modulars and create components that takes also some configuration inside. Later on, you have microservices, also things which deployed independently. In some point in one day, you need kind of system of systems. You need some independent system that deploy end-to-end and support end-to-end functionality. And this team follows this rule. They really good in this way. So you have keeps this rule and produce their independent teams that implement. So the team said, if you go other way, have no chance to be successful with this project. So they really make a good job. So they also split the front-end part, that's every team responsible for own piece of front-end. But what was the problem? There are some things that really hurt the teams. Is the first one, they have no concept how to integrate different user interfaces. And this was done ad hoc, have performance problem, and have also support and maintenance problems. So I have no idea how to do it. Also, API styles and formats was quite different between the teams, and it produced additional efforts to integrate them. Yeah. So I don't talk about some canonical model. It's not necessary to have, and I don't recommend to have, but some formats. For example, some teams use JSON Hull or JSON Siren or some difficult formats. So yes, also produce some additional effort to understand the same kind of information for communication between the teams. And the last problem was, despite of not centralized front-end, they have centralized front-end team that immediately created bottleneck. So every centralized stuff, that's my experience of the large projects, will be quite fast bottleneck in this case. So idea is, if you ignore completely for architecture decision, you cannot take it. That's not mean that this system, so you avoid, you skip this exercise. Yeah, you still, system will have some architecture aside, but perhaps not the architecture what you desired. So if you don't think it upfront and don't make an architectural decision where it's necessary, you will end up with something perhaps what you don't want. And also, there is a very fine line between diversity This is really good and added value that the team works independently, make independent decisions. It's really nice, and also try innovation. One team try innovation that can show for other teams that they can also profit for that. Try new frameworks, new kind of work, and from other side, it counts what really hurts and make development process slower and less clear. I also think that the loose coupling really requires few rules, but they need to be enforced, need to be followed very strictly. It sounds a bit stupid, but exactly these rules ensure the loose coupling. For example, you say that, for example, it's not possible to have direct database connection. You can go only for the API, or you cannot call this method directly. So there are only a few rules, and all teams should follow them. On all other stuff, like, I don't know, code formatting, which version of library use is, of course, team decision. So team has a lot of flexibility, but only should be compatible and keeps these few rules that ensure local coupling. Questions, any suggestions? Because now I make some takeaways, some conclusion. So the first, I would say, not afraid about architecture is not so bad. It's not only enterprise architecture that's completely decoupled from the team and makes something that nobody understands. So architecture could be done by everybody, and we need to have to make these architectural decisions. It's also not so bad, not so difficult, and it's not a job that only dedicated person can make. Second, I would say choose the simplest things that will work. So be pragmatic in this case, but think about that the system could evolve, and could be the case that architecture decision what you make now in 1 year or 2 years is stupid and should be changed, and it's also okay to change it. So this, of course, a bit trade-off between this pragmatic case and flexibility, but it's with experience, it's quite a good balance. For example, microservice architecture or model architecture or component architecture will help, because in the worst case, if your architecture sucks, you can just remove the component of microservice and completely replace it to something new. Yeah. So this is the way how to achieve this flexibility. You don't know what's changed in the, or either it will change in the future, but you have a good possibility to take away one part of the system and replaces with something different. Yeah, that's basically all from my side. Any general question about any case what I presented last time and this time, or any remarks?
Hi, Andrei. I have a quick question regarding the last case you mentioned.
Yeah.
So basically, what was the solution in their case? I guess they have to apply some strict structure so they don't decoupling. Yeah, this one.
Yeah. The strict structure is not necessary, but they need some kind of strategy. So if each team produce own user interface, we need perhaps to align the styles. So it should be style should fit, and we should have a strategy how to integrate it together. So how will links works, who will responsible for central part, and how they integrate. For the API, I also not recommend to have kind of canonical model to strict structures that all the teams will follow. So that data model is decision of the team, and API decision of the teams. But despite of that, it makes sense to agree on some format, for example, of exchange data. If we have a JSON format, how we'll use hypermedia or not, and keep it in the same way, how we document the API. So it's this kind of agreements between the teams make sense and make work easily and more efficient. So as how to achieve it, we have normally 2 or 3 people for each team who play a leading role or architectural role, and they have some meeting together and could agree to this rules. So it's only few rules, but they are should be strictly followed. Also, the completely free development in the team has downsides. So still need to think about architecture as a big one.
Okay, I got it. Thank you.
Any other questions or remarks or experience that you would like to share? Okay, if not, I will stop the recording.